Section 6 is a little bit trickier to do via video. I would much rather have a discussion with you and be able to bounce these off of you back and forth. But this is the way we're going to do it, so let's try it. And if we need to discuss it more in class, we can do that. Because lesson 1.6 is translating word phrases into mathematical expressions. So the first thing you need to know is that math is a language. Just some of you are taking Spanish and you take English words and you can translate them into Spanish words, and they mean the same thing, but they're understood by different types of people. Math is the same way. You can take English words and then translate those into numbers and letters that, see, to me, they make all the sense in the world. And they will to you in time also. So here we go. So math is a language. So the trick is to start recognizing phrases that can directly translate into the math language. So there are certain phrases that just mean add, sum, added to, put together, the total. Those are types of things. And if you'll look at page 63, there's a chart. There's a whole chart of these. I'll try to make this lesson really short so that you can please spend some time looking at that chart and look at some of those phrases. Let's see, more than, increased by. All of those mean adding. Subtracting, that would be subtracted from, taken from, less than, decreased by. All of those mean subtract, take something away from. The difference between, that's also subtracting. Multiplication, one thing that you need to know of means times. If you have something, if you have 1/2 of something, that means times, multiply it. Let's see, twice, 2 times, the product of, some number multiplied by, those all mean multiplication. Division is either divided by or the quotient of. Let's see, ratio. The ratio is also a division problem. So all of those terms, you need to start recognizing them so that, honestly, so that when they're in a word problem or in real life, you can translate those into math so that we can solve them and all come up with the same answer, because you know that's what I love. So today, let's just look at a bunch of them. Before we do that, there are a few that I mentioned: less than, subtracted from, and divided into. All of the others, if you say 6 added to a number, that's just going to be 6 plus x. But if you say 6 less than a number, instead of being 6 minus the number, it's going to be the number minus 6. So less than kind of turns it backwards from what it seems like the words are saying, because we're saying 6 less than means we're going to take the 6 off of what we started out with. The same with subtracted from. 6 subtracted from x comes later instead of 6 minus x, the way it would be written in the sentence, it flips it mathematically. So 6 subtracted from x is actually x minus 6. So make sure you notate these so that you know these are the ones that you flip. The less than, subtracted from, divided into. 6 divided into a number, instead of being 6 divided by the number, is going to be the number divided by 6. So 6 divided into the number is going to be backwards from what you think it should be. So less than, subtracted from, divided into are backwards. So now that you see that, let's just do some. All right, and they're going to first look like gibberish to you, and hopefully the more we do, the more, oh, I'm starting to see it. So 4 is easy. That's going to be a number. More than is going to be adding. 3 times a number, 3 is a 3. Times is a multiplication problem. A number is something we don't know, and so there's your unknown, there's your x. Notice that I'm using a dot for times instead of an x times sign, because the number x we're going to notate with an x, just so that you're clear there. So here again, the more than, just like the less than, would be opposite, but with addition, it's not as important. So in this case, either one will be correct. We can either have 4 plus 3 times a number, which would be just 3x, or we can have 3x plus 4. And either one, this is actually more correct because the more than kind of turns it around. 4 more than 3 times a number indicates we started out with 3x and we added 4 onto it. So either of those would be counted correct. Here we go. 6 is the number 6. Less than is a subtraction, but remember that's one of the ones that flips it backwards. So 6 less than the square of a number. So the square of a number is going to be the number squared. So 6 less than is going to switch it. So minus 6. So 6 less than the square of a number, x squared minus 6. So it's easier if you kind of translate, just like you would if you were translating another language like Spanish. You go in first, you individually, you find each word that you can translate, and then you put it together into a sentence that makes sense. That's what we're doing here. Just take each part. 1/2, well, that's just 1/2. Remember, of means times. Oh, a number v is just v. Divided by, okay, that's easy. The square root of t. So the square root of t. All right. So half of v. So that would be just 1/2 v. Divided by, you can either use the symbol like this, divided by the square root of t, or if you prefer, and I kind of prefer the fraction look, I don't know why, I just do, it doesn't matter. So you can do that. In this case, I wouldn't necessarily do it because you already have a fraction here, but it's perfectly fine if you wish. 1/2 v divided by the square root of t. That ends up getting a square root in the denominator, which we don't necessarily like. So this is still true, but I would probably have this one just stay this way. All right, so this would be the preference, but that one is true too. Okay, 5 is a 5 times, now we got to be careful because this says the sum of x and y. Okay, so now we're going to take 5 times something. We're going to take, oh, that's lovely. 5 times something, but we're going to take 5 times a sum. So the sum means we're going to add something. So in this case, we're going to multiply the 5 times a sum. So we've got to add it together first. So we've got to show that we're adding something together before we're multiplying that. And remember, in your order of operations, if it's in parentheses, you're going to do it first. So let's say the sum is going to be inside parentheses of x and y. So we're going to add the sum we said is adding. So x plus y. So this is 5 times the sum of x and y. All right, now let's see how this differs from the sum of 5 times x and y. So this looks very similar to this, but in the translation process, we've got to be careful. It's almost like the tenses have to be right here, okay? So the sum of, that says we're going to add 2 things. So we're going to add something. So the sum of what? The sum of 5 times x and y. So do you see the difference between this one and this one? This is 5 times the sum. And this is the sum of 5 times x and y. So it's where does that and come in, and where is the word sum and where's the word and? So make sure you read carefully. All right. Last one of these. The product of x and y. So product is multiply, and x and y are just x and y. The product of x and y divided by, so we can either use a division sign or a fraction sign, remember, divided by the sum of x squared and 5. All right, so the product of x and y, we're going to multiply x and y. So we can just put them right next to each other to show the product of x and y divided by, and you can either put a division sign, or here I like to put a division bar, but if you would like, we'll do it the other way in just a minute. Divided by the sum of x squared and 5. So the sum is x squared plus 5. So that one would be the same as the product of x and y divided by the sum of x squared and 5. So either one of these would be correct. All right, and now, right now, it really might look like, oh my word, that's just a bunch of words and it's just a bunch of craziness. Take each one step at a time and look for the pieces and just translate the parts that you know. And if you don't know, well, what does less than mean? I don't remember. Go back to your chart and find out what those mean, all right? And look at each part and piece and pull each part out, and then you can start seeing. I promise it'll start getting easier the more you do. The last thing, of course, I can't end without a word problem. You would think that all of this words would be enough words, but no, I want to do a word problem. Here's where scientists and mathematicians use this a lot. So let's give you a kind of a science-ish kind of a word problem here. Two asteroids are on a collision course. We calculate the time to impact by dividing the distance separating them by the sum of their velocities. So how on earth can we put that into a mathematical formula so that we can find out when on earth are they going to collide, and can we do it in time so that they don't collide before we figure it out? Yeah, that's the real problem, real question. Anyway, okay, so two asteroids on a collision course. We calculate the time to impact by dividing, so there's a division, dividing the distance separating them, so whatever that is, and we're just going to call it D because we don't know. If we knew that distance, we would put it there. By dividing the distance separating them by the sum, so we're going to add something, the sum of their velocities, and we'll just call them V sub 1 and V sub 2 for the two different asteroids. You can call them whatever you want. So let's divide, we're going to have a division problem, the distance by the sum of their velocities. Easy, right? There you go. From there to there, easy. You could also remember, since it's division, you could also write it, if you would prefer, D divided by with that type of sign. Make sure that you have your parentheses around your sum, and that would be the exact same thing. All right. Good luck on your translating. I hope it goes well. I will see you soon.